True or false? At our company, safety is important. Very important. Answer: true, of course. Easy question, but the answer has deeper meaning. Our goal of maintaining a safe work environment is vitally important, and it's more than just words. It's backed up with specific rules and guidelines that, if followed correctly, can help ensure that at the end of your workday, each and every one of us goes home in one piece and in good health. So it's our mission: no accidents, a healthy workforce, and protection of the environment. The key to making that statement a reality is both understanding and following the 8 best practices for success, which we will cover in this program, including recreations of actual incidents to underscore the consequences of not fully using each best practice. Before we examine the practices in detail, it's important to understand our commitment to health, safety, and environmental performance. Everyone is responsible for getting safety, health, and the environment right, and good performance in all 3 areas is critical to the success of our company. Key points embedded within the 8 best practices include the following. Work should be conducted with a pre-job risk assessment and a safety discussion appropriate for the level of risk. All persons should be trained and competent for the job. Personal protective equipment should be worn based on the risk assessment and minimum site requirements. Emergency response plans, developed from a review of potential emergency scenarios, should be in place before commencement of work. Everyone has an obligation to stop work that is unsafe. The 8 best practices apply to the following areas: permit to work, energy isolation, ground disturbance, confined space entry, working at heights, lifting operations, driving safely, and management of change. We'll now examine each topic in detail and give examples of how they impact your daily operations. Let's start with permit to work. Before conducting work involving confined space entry, energy systems, ground disturbance in locations where buried hazards may exist, or hot work in potentially explosive environments, a permit must be obtained that defines the scope of work, identifies hazards and assesses risk, establishes control measures to eliminate or mitigate hazards, links the work to other associated work permits or simultaneous operations, is authorized by the responsible person or persons, communicates all the preceding information to everyone involved in the work, and finally, ensures adequate control over the return to normal operations.
Okay, Mark, what we got going
When
on
working
here,
on a permit-required work site, you must make sure a work permit has been issued.
Picking all that up, doing all of our pipe fabrication.
You already got all your hot work permit and everything?
Yes, sir.
The permit is a job safety checklist that helps identify potential hazards and ensures that proper control measures and emergency procedures are put in place. Depending upon the task, the permit may be accompanied by additional risk assessments, such as the pre-job task hazard or job safety analysis. The company representative in charge or designated person must issue all permits for that site. The permit should not be issued until the equipment is verified as properly isolated and depressured, all permit and associated risk assessments have been documented and communicated. Close the permit at the end of each shift. A new permit and appropriate risk assessment must be issued at the start of each new shift as long as the project continues, or when conditions change during a shift, such as inclement weather occurring. This applies even if the job itself has not changed. A closed permit with attached documentation should be retained according to your company's record retention. Now let's take a look at a reenactment of a real-life incident regarding permit to work.
did not see anybody. Well, ain't no.
Hey, Mark, what you got going on
Johnny,
up here, buddy?
I am so sorry. I did not see you. I was sitting there blowing that thing down, and man, I didn't know you were supposed to be over here.
Yeah, we got some cutting and welding going on over here.
Man,
I've got a GSA rat and a hot work permit I need you to sign off on,
that's
buddy.
what we should have already done. I'm sorry, man. Let's go take care of it.
Okay, come on, buddy.
Man, I am sorry about that. I didn't mean to do that.
Okay, Mark, what we got going on here is we've got a new pipeline we laid. We're tying into some separators, hooking all that up, doing all of our pipe fabrication.
Okay, let's move on to the second safety practice, energy isolation. Any isolation of energy systems, whether they be mechanical, electrical, process, hydraulic, or any other type, cannot proceed unless the method of isolation and discharge of stored energy are agreed and executed by a competent person or persons. Any stored energy is discharged. A system of locks and tags is used at isolation points. A test is conducted to ensure that the isolation is effective. Isolation effectiveness should be periodically monitored. Energy isolation is important because unexpected energizing, startup, or release of stored energy could result in an incident. A lockout-tagout procedure should be used when performing maintenance or repairs on energized machines or equipment. Employees involved in the lockout-tagout should fully understand the energy, hazards, and methods of energy control related to the equipment.
Hey Billy, we're fixing to isolate a pump. We'd like to see if
All
you can give us
affected
some
employees should be notified about the lockout-tagout procedure. Machinery or equipment must be turned off or shut down using established procedures. Energy isolating devices must be properly installed once the equipment has been properly de-energized. De-energized equipment should be locked out with an approved lock. The tag should be dated and signed by the person performing the work and attached to the lock. If different groups are working on the same equipment, the authorized person from each group must lock a multiple hasp and sign and date the Danger Do Not Operate tag. When the area is clear, the locked-out equipment must be tested to verify it will not operate. At the beginning of a shift or after a meal or break, lockout-tagout should be re-verified to ensure no one has returned the equipment to service. If there's a possibility of reaccumulation of stored energy to a hazardous level, continue to verify the isolation until the repair or maintenance is complete or until the possibility no longer exists. When work is finished, ensure all locks, blinds, and tags are removed and equipment is returned to operating position before startup. The person in charge should also sign the permit. Now here's a real-life incident relating to energy isolation.
What you are about to see is a recreation of an incident that occurred late one summer afternoon at this drilling rig.
Okay, when I came on tower, it was our first day back. We'd been on our 14 days off and got here, and my relief, the other motorman told me I had to change out the pulsation dampener on the #1 mud pump. So I said, okay, and we talked about all the other things we had to do. So I finished all the other things we had to do, and it came time to go start work on the pulsation dampener. So I went and I told the driller that I was going to start work on the pulsation dampener, went down to the mud pump room and locked it out electrically there, shut in the 4-inch mud line, which goes to the rig floor, then went to the SCR house and I turned off the 3 of the motor controllers for the mud pump, the rotary, the blower, the chain oiler, and the rod oiler. And then I turned around to turn off the charge pump and I noticed he was still using it. So I went back up on the floor and asked him to switch to the other charge pump so I could go ahead and work on that, specific mud pump. And he did. And then I was on my way back downstairs to lock it out and I got sidetracked by somebody had a question, then I had to go fix something else and and I forgot to lock it out. And then I finished all the other things that I was doing for the other people, and I went and started working on the pulsation dampener. Well, then it came time for relief, which I'm the relief driller at dinner time, and I relieved the the driller up on the floor. They were coming out of the hole, and they were just about out of the hole. Finished getting out of the hole, and it's standard practice to shut the charge pump off, monitor the well, you know, observe it, make sure that it's not flowing or taking any fluid at that time, and then close the blind rams. And in the winter, we always leave a charge pump running over the top of the hole so the lines don't freeze up. So I did that. I checked the, you know, the well and everything like that, went and shut the blind rams, came right back, and I turned on the charge pump on the pump that I was working on. Alan, the tool pusher, called from camp and said, "You've got mud coming out of your pump room." I shut the charge pump off, and we went downstairs and saw that, you know, I'd put a little bit of mud on top of the complex and down on the Herculite.
A small amount of water-based mud ended up on the ground outside the rig. Cleanup was completed in less than 40 minutes with no impact on the environment, but a lasting impact on the motorman.
Well, something I've learned out of it, I've got 23 years of experience in the oil fields. I was a company man, I pushed tools, drilled, and on down the line. And I just assumed, which I shouldn't have. You know, I assumed that since I had gone through the motions of, you know, starting to lock it out, that I had totally locked it out, but I hadn't. And that's the biggest thing is to, what I do now is not only do I go lock something out, but then I'll double check my lockout, and then I have the, you know, whatever the piece of equipment is that I'm working on tried at a different station to verify that it is locked out. So I've got a little three-way check now that I use when I do it.
All right, let's move on to ground disturbance best practices. A ground disturbance is a man-made hole or depression in the Earth's surface, such as an excavation or trench excavation. A trench excavation is a narrow cut where the depth is generally greater than the width, but the width at the bottom is not greater than 15 feet. A professional engineer must design excavations greater than 20 feet in depth. Check with your supervisor for your company's regulations and procedures on excavations. A ground disturbance permit is required whenever power mechanized equipment or penetrating tools are used. Ground disturbance work can only proceed once the following occur. A hazard assessment of the work site is completed by a competent person. All underground hazards, such as pipelines and electrical cables, have been identified, located, and, if necessary, isolated. When people are about to enter an excavation, a confined space entry permit should be issued if the entry meets confined space definitions. Ground movement should be controlled and collapse prevented by systematically shoring, sloping, or benching as appropriate. Ground and environmental conditions must be continuously monitored for change. Notification requirements, as well as permit length, vary by location. Workers must be familiar with and obey the laws applying to their specific areas. Any trench or excavation greater than 4 feet deep should be considered a confined space and treated as such, unless mitigating circumstances exist. Consider specific excavation methods such as soil type, consistency, natural angle of repose, slurry disposal, contamination, pre-excavated and spoil pile placement. Make note of the size of the excavation, proximity to traffic, stability of adjacent improvement, structures, vibration-producing equipment, load placement distances, and weight distribution relating to the excavation. Follow proper methods to stabilize excavation faces, ramping, and proper access and egress points, and be aware of environmental degradation factors such as heat, cold, water, and soil fluid pressures. When planning the work to be carried out, consider the number of workers, tools, and equipment needed in the excavation, PPE requirements, and the need for a safety standby. Again, if you have any questions relating to your company's rules about excavating and trenching, contact your supervisor. Okay, let's take a look at an incident relating to ground disturbance.
Hey, did you get as much rain as we got last night?
Yeah, we got like 3 inches. Do you think the ground's stable enough to dig today after the rain?
I don't think it's going to affect us what we're doing today.
Now let's move on to confined space entry. A confined space is an enclosed or partially enclosed area not intended for human occupancy, except for work purposes, and has restricted means of entry or exit. Entry into any confined space should not proceed unless all other options have been ruled out. A permit is issued with authorization by a responsible person. The permit is communicated to all affected personnel and is posted. All persons involved are competent to do the work. All sources of energy affecting the space have been isolated. Testing of atmosphere is conducted, verified, and repeated as often as defined by the risk assessment. A standby person is stationed. Unauthorized entry is prevented. There are 3 levels of confined space, classes 1, 2, and 3. Class 1, no hazard. A confined space where there is no threat of a hazardous gas, vapor, dust, or fumes. Oxygen content falling below 19.5% or rising above 23%. Entry requirements. Communication with backup. Atmospheric testing if applicable. All PPE identified and worn. Rescue plan in place. Rescue equipment readily available. Class 2, potential hazard. A confined space where there is a potential for a hazardous gas, vapor, dust, or fumes. Oxygen content less than 19.5% or more than 23%, which has been purged, ventilated, and maintained with a safe atmosphere. Entry requirements. Confined space permit. Lockout-tagout procedure followed. Isolation procedure followed. Continuous atmospheric testing mandatory. Confined space purged and ventilated. Rescue plan in place. Rescue equipment set up and ready for use. Safety watch or attendant. Full body harness and lifeline. Wristlets are not allowed. A full body harness is required. Class 3, hazard exists. A confined space where there is a possibility of a hazardous gas, vapor, dust, or fumes. An oxygen content less than 19.5% or more than 23%, which cannot be ventilated to provide and maintain a safe atmosphere. Entry requirements. All requirements listed in Class 2, plus breathing apparatus mandatory for all personnel entering. Please note that for process piping, blinds must be used to block fluid flow. Proper blinding procedures must be followed for installation and blind removal. The designated standby person should be stationed at the opening of the confined space and be able to communicate with both the rescue team and the workers inside. They should also be aware of the dangers posed by carbon dioxide. CO2 makes up about 1% of the volume of dry air and can cause death by suffocation in confined spaces if inhaled in large amounts. Any problems encountered during an entry operation should be noted on the permit. While workers are inside, they should continue to monitor the confined space. If a change in condition is experienced, they must exit the space until conditions have returned to normal. Your company may have additional rules or procedures related to confined space entry. Contact your supervisor for specific details. And now here's a real-life incident relating to confined space entry.
Kenny, has that been calibrated?
I calibrated at the office. Okay, looks good, but the batteries are beginning to get low on this. Danny, would you go get your meter?
Yeah, I can do that. I put fresh batteries in mine this morning.
Has it been calibrated?
Yeah, I calibrated.
Looks good. Whoa, hold it, Danny. There's no O2 sensor.
Oh yeah, I took that out. It was bad. I just been using it for LEL.
We need an O2 sensor for a confined space permit, so I'll take the sensor out of mine and put in it.
Now let's review working at heights. Working at heights of 6 feet or higher can only proceed when the following are in place. A fixed platform is used with guard or handrails, verified by a competent person or persons. Or, fall arrest equipment is used capable of supporting at least 5,000 pounds of static load per person and has a proper anchor mounted, preferably overhead, a full body harness using double latch self-locking snap hooks at each connection, synthetic fiber lanyards, a shock absorber. Fall arrest equipment that will limit free fall to 6 feet or less. A visual inspection of all fall arrest equipment and systems prior to use is completed, and any equipment that is damaged or has been activated is taken out of service. The person or persons performing the work are competent to do so. The fall protection harness must be worn properly, with the straps placed in the middle of the back, not on the sides. The importance of the required shock absorber cannot be overstated, nor can the fact that this equipment only works once. If used in an incident, it must be discarded and replaced. A fall protection plan is required when working at heights above 6 feet. If you have questions or need further clarification, contact your supervisor. Time now for a real-life incident relating to working at heights.
What you are about to see is a recreation of a serious potential incident that occurred at a workover rig site like this one. The crew is performing routine well service, and an experienced hand is on tour as derrickman.
Well, the crew is getting ready to run pipe in the hole out of the derrick. The derrick man ascended the ladder using his anti-fall device. He got to the board and went over to the back of the board, hooked his lanyard, he thought, onto the back of his harness, then unhooked his anti-fall equipment from his harness. At the time, the crew was busy down on the floor getting some equipment prepared, so he had about 10 minutes before he had to latch any pipe. He sat down at that time and waited for them to get done. Then when they were ready to run in the hole with the pipe, he walked across the board with a first stand of pipe, took the pipe, threw it in the elevators, and at that time he realized that he was not latched on. Fell across the pipe itself, grabbed onto it, wrapped his legs around the pipe, and slowly descended the pipe, reaching the floor about 60 foot below, unharmed, unhurt.
The lucky derrickman shrugged off the incident and attempted to return to work immediately, but was stopped by the driller.
You go up there and you kind of forget about the proper procedures. You're so used to being up there that you don't realize the dangers involved.
Okay, time for lifting operations. Lifts using cranes, hoists, or other mechanical lifting devices will not commence unless an assessment of the lift has been completed and the lift method and equipment has been determined by a competent person. Operators of powered lifting devices are trained and certified for that equipment. Rigging of the load is carried out by a competent person. Lifting devices and equipment have been certified for use within the last 12 months at a minimum. The equipment used to certify these devices and equipment must also be certified to perform the required tests. The load does not exceed the dynamic and/or static capacities of the lifting equipment. Any safety devices installed on the lifting equipment are operational. And all lifting devices and equipment have been visually examined before each lift by a competent person. Lifting, whether using simple hand-operated mechanical devices or more complex ones, must be carried out by trained and competent persons using approved and recently inspected equipment. The area underneath or potentially affected by the lift must be kept under control and clear of persons or equipment. Only trained personnel are authorized to operate cranes and hoists and prepared to rig up for lifting. All cranes, hoists, slings, and wire rope must be properly inspected, maintained, and operated according to the manufacturer's recommendations, API recommended practices, OSHA regulations, and company policies and procedures. As with other operations, every employee is authorized to stop any unsafe lifting procedure. As a crane operator, you must have a sound working knowledge and understanding of the use of the hardware and equipment, the ability to read, understand, and implement a lift plan and drawings, a thorough understanding of the hand signals as required by OSHA and developed by ANSI, the ability to recognize hazards and risks within the lift area, have a clear understanding of lift dynamics, and have previous experience or familiarity with a particular type of lift. As a rigger, you must have knowledge of the equipment, experience with lift procedures, a working knowledge of relevant standards codes and practices, the ability to prepare and interpret site and lift plans and drawings, knowledge of hand signals. Maintenance requirements include the following. All rigging equipment must be inspected prior to use to ensure that it is in good working condition. All cranes and hoists must be inspected and maintained as per the manufacturer's guidelines. All documentation must be available on site. All lifting devices must be certified and labeled by a professional engineer. All damaged equipment must be taken out of service immediately. Qualified mechanics or qualified operators must do repairs. Repairs to critical components, structural parts, ball ring bolts, wire rope, winches, shivs, pins, boom sections, must be done by a qualified inspector. Operation, maintenance, and inspection records must be maintained. Check with your supervisor for specifics on which records must be kept and for how long. Operation requirements include the following. When making a lift, a flagman is required. He's responsible for directing a blind lift, watching out for obstructions, and keeping people clear of the danger area. Each crane must have a substantial durable rating chart. Cranes must be operated as per the manufacturer's guidelines. The area of the lift over which the load is carried must be barricaded to prevent anyone from getting under the load. A critical lift plan must be developed for lifts over operating equipment when the total load exceeds 80% of the crane's load chart, or where 2 or more cranes are required to lift a single piece of equipment. All unnecessary personnel must be outside the barricaded area. No portion of the crane must come within 9 feet of any power line unless the power line contains less than 50 kilovolts, in which case the distance to crane limit is 10 feet. Crane hooks must be equipped with positive safety latches. Now let's look at a real-life incident relating to lifting operations.
All right, that's it for the rat. Buster, I know you're new to this crew, but we need you to do the hand signals. Chris will operate the crane. I'll guide the head in on the guideline. Go ahead and sign this rat and let's get started.
Ready? Ready. Bring it down, Chris.
Go up a little bit. No, come back from this way. Just a little. Come on. No, no, go back the other way, Chris. A little more. Come on, back a little more. No, go back to the right. Come on. Too much. Go back to the right. Go back to the right. Go left. Go left. Go left. Back to the left. Left. Whoa, whoa, whoa. All right, just stop, man. Hold it. No, hold it. Stop.
Buster, you know how to do hand signals?
Not really, I don't.
We need to talk about this.
Chris, let's go ahead and shut the job down for right now. All right. Okay, let's review some hand signals. Here's the ANSI OSHA signals that we use here. This would be the signal for up. This is the signal for down.
The next best practice covers driving safely. All categories of vehicles should not be operated unless the vehicle is fit for purpose, inspected, and confirmed to be in safe working condition. The number of passengers does not exceed the manufacturer's design specifications. Loads are secure and do not exceed manufacturer's design specifications or legal limits for the vehicle. Seat belts are installed and worn by all occupants. Safety helmets are worn by riders and passengers of motorcycles, bicycles, quads, snowmobiles, and similar types of vehicle. Drivers must not be authorized to operate the vehicle unless they are trained, certified, and medically fit to operate the class of vehicle. They are not under the influence of alcohol or drugs and are not suffering from fatigue. They do not use handheld phones and radios while driving. Best practice is to switch off all phones and two-way radios when driving. Operation of road transport of all kinds is the source of the greatest number of serious accidents and fatalities. The two key components of getting road safety right are access to the right vehicles with appropriate equipment, standards, and procedures, the quality of the training and competencies of drivers together with their behaviors and attitudes. Driving safely applies to commuting to and from work and driving rental vehicles for company business. Plan the time required to drive to and from the location as part of the workday and schedule accordingly. Driving safely requires constant attention and awareness of road hazards, and the following tips should be kept in mind. Change drivers or take a nap if you're too tired to continue driving. Stay alert. When tired, pull over, take a break, walk around, and stretch. Do this every 2 to 4 hours. Drive defensively. Be ready to take alternative action if something goes wrong. Drive slowly and take note of road conditions. Before entering the vehicle, a walk-around check must be performed to verify the vehicle is in good condition and no hazards exist. The vehicle must be checked and inspected regularly. Always wear a seatbelt. Always turn on the headlights when driving. Never exceed the posted speed limits. Slow down or stop if the road is slippery or in poor condition or visibility is restricted. Be wary of oncoming traffic and slow down when approaching a hill. When parking your vehicle, always park ready for an exit, that is, backing your vehicle in a parking space, pointing away from a well site or facing an entrance. Eliminate or minimize distractions while driving. Because cell phones should not be used by the driver while he or she is driving, be courteous when calling another employee's cell phone or radio. Ask them if they are driving and whether they can talk safely. When towing another vehicle, use the manufacturer's recommended tow hooks and ropes and inspect them before use. The preferred method of towing is the use of a tow truck. Drugs and alcohol are not allowed in vehicles at any time, and firearms are prohibited in vehicles and at work sites. Okay, time for a real-life incident relating to driving safely.
Yeah, this is Mike.
Yeah, I've got a triplex plunger vacuum linked with the T-bed and the new pump at C39. Can you come take a look at it?
Yeah, oh yeah, I'm on the way. Dang it! Where did he come from?
Our final best practice addresses management of change, or MOC. Work arising from temporary and permanent changes to organization, personnel, systems, process, procedures, equipment, products, materials, or substances, and laws and regulations can only proceed once a management of change process is completed, where applicable, to include a risk assessment conducted by everyone impacted by the change, the development of a work plan that clearly specifies the time scale for the change and any control measures to be implemented regarding equipment, facilities and process, operations, maintenance and inspection procedures, training, personnel and communication, and documentation. Authorization of the work plan by the responsible person or persons through completion. The management of change plan is designed to document and receive approval for both permanent and temporary changes. The purpose is to identify and control potential hazards associated with the change. MOC ensures that the impact of the changes that affect the health and safety of personnel or threaten the environment are properly recognized, reviewed, approved, communicated, and documented. In an extreme emergency, it may be necessary to carry out a modification or procedural change before normal MOC procedures can be followed. These changes require the verbal authorization of the designated person in charge and should be subjected to normal MOC procedures at the earliest possible time. Remember, these situations are the exception to the rule and occur rarely. Vigorous effort should be made to carry out normal MOC procedures at all times. Step 1. Initiation. Determine if a change is required, and then complete an MOC form to justify the change. The originator of the proposed change must clearly communicate to line management a description of and reason for the change. Step 2. Preliminary authorization. The evaluation team reviews the MOC documentation and gives authorization for the changes to occur. An appropriate risk assessment or job safety analysis must be included at this stage, and input from other operations personnel should be solicited. Step 3. Technical and HSE review. Once the detailed work on the MOC is complete, the project manager determines what level of review is required, such as HAZOPs, PHAs, what-if analysis, and technical HSE checklists. The review assesses hazards associated with physically implementing the change, as well as hazardous effects that the change could have on process and personnel. Step 4. Final authorization. Management approves of the changes, which occurs in 2 stages: approval of the necessary project and approval of completion after startup. Prior to implementation, the changes must be properly communicated to affected employees. This can be accomplished through the pre-job safety meeting process or directly by the supervisor. Step 5. Records. All information regarding the MOC is filed for future reference.
Hey Carl, how's it going?
Hey, Ron.
Having a little trouble with the new unit?
No, I just heard some noise and maybe thought I'd stop it and grease it.
Everything else going all right? Is it running pretty good? I know we've had it on a couple of days.
As far as I know, everything's ready.
Hey, well, let's fire her up then.
Okay.
That discharge been set on?
Well, I looked at that a minute ago, and I thought that was kind of low. It was down there on 375, and I bumped it up just like the other machine is down there.
No, you know, this is a different application with this new unit. If we set it up there, it gets up to that pressure, something's going to go on the unit before it shuts down.
Well, I didn't have any records to go by. This being a new installation, I'm used to looking back at the day before every day and looking at my records, and this is brand new. And
yeah, it's a little confusing. That really should have been caught on the training issue with the MOC. I'm really surprised it wasn't. Matter of fact, we need to go over here to the office and let's call down there and look at the files and see what the deal is on that.
Okay.
Okay, I have that MOC right here. That's for the Little Martin compressor, the high pressure shutdown.
Our workforce is carefully selected and trained to ensure that everyone is competent to perform the tasks they face and will go home at the end of the day safe and in good health. Your willingness to learn, understand, and follow through with the best practices you've just seen is critical to our operating success and to the continued safe operation of our enterprise.